Hello and welcome. This is the first video for topic 4, machine learning, and this is for the IB Diploma in Computer Science. We're going to be looking at machine learning fundamentals. As you can see here, we're looking at the A's, the concepts of computer science. This is the final topic where we did dedicate 5 hours for standard level and 18 hours for the higher level students. This is broken down into 4 parts. If you're doing a standard level, you're really looking at 4.1, which is what we're doing today, and 4.4. Those doing higher level need to look at data processing and machine learning approaches. Okay, so what are we going to cover in this video? Well, there are 2 objectives, 2 things. Types of machine learning and their applications. This is 4.11, and 4.12, hardware requirements for machine learning. For part 1, we need to define AI, machine learning and generative AI. We need to distinguish between the different types of machine learning, explore real-world applications. And then for the hardware requirements, we need to identify platforms for machine learning, compare CPUs, GPUs, TPUs, NPUs, ASICs and FPGAs, and explain edge devices, cloud platforms, and HPC centers. Okay? So in this first part, we need to look at different machine learning types and their applications. And by the end of this video, you will understand the difference between artificial intelligence, machine learning, and generative AI. You'll be able to explain the 4 main types of machine learning and recognize real-world examples where these are used. Okay, here's a robot reading a book. Hopefully the robot's learning too. So first of all, let's just break it down and back to basics. What is artificial intelligence? Artificial intelligence is like giving computers brains to do tasks that usually need some kind of human smarts, human intelligence, like playing games or recognizing faces. It's a big field that includes machine learning as one part. Generative AI is a cool type of AI that creates new things like drawing pictures or writing stories from scratch, e.g. tools like DALL-E, you may have come across, for imaging, and of course ChatGPT, the famous one, for generating text. Try to imagine AI is like a super smart video game character that learns from playing. The more you play, the more the character learns what to do and which way to go. But what is machine learning? Machine learning is part of AI, which is what we sort of looked at previously on the sort of a circular Venn diagram, where computers learn from data without being told every single rule. Instead of programming exact steps, the computer finds patterns in examples. A real-world example might include your face's biometric face scanner, which learns from photos of your face. Okay, the more you scan your face, the more it sees photographs of your face, the more likely it is to be accurate in terms of when and how it unlocks your phone. Types of machine learning and their applications. So several different types of machine learning. We're going to start here with deep learning. Okay, again, this was in the diagram previously. Deep learning is a type of machine learning that uses artificial neural networks, ANNs. Okay, these are inspired by how human brains work. They're made up of connected neutrons, or nodes in this case, that pass information between each other. So it's a little bit like, as you can see here with the brain, we've got the input, we've got the nucleus, and the cell body, and this is going down here until it gets to the outputs. Neural network is designed in the same way. We've got a series of inputs feeding into the linear and activation function, and this will then generate the outputs. Deep learning stacks many layers of neurons. Each layer learns more detail. For example, in image recognition, one layer might detect the edges, another layer sees the shapes, and the final layer recognizes the objects, such as a car or a face or an animal, a dog or a cat. Deep learning has changed the way we use technology. It's behind speech recognition, chatbots, self-driving cars, and even image generators. Supervised learning. In supervised learning, the computer is supervised with data that has correct answers or labels. There are 2 main kinds. Regression, which predicts numbers like guessing house prices based on size and location, and classification, which puts things into categories like deciding if an email might be spam or not. Again, real-world examples of this include music apps, classifying songs or pop, rock or hip-hop genre, and handwriting recognition, turning your scribbles into letters or numbers. See here, which one's the dogs, which one's the cats. It's using labeling to sort of say, okay, this is a dog, this is a cat. Note, it is like a teacher grading your homework and showing you, and writing notes on your homework, showing you the right answer to help you improve. That is if you read your notes. Unsupervised learning, unlike supervised learning, has no labels or answers. The computer explores data to find patterns of its own. The main ways in which this works, firstly, clustering. It groups similar things together, like sorting friends by their interests. And then there's association, which finds connections like people who buy bread often buy butter. Again, real-world examples might include social media analyzing likes and follows to suggest groups, e.g. those who like dogs might suggest puppy lovers, shops using purchase data to spot trends and tailor ads for potential customers, and Netflix recommending shows, grouping similar views to what maybe other viewers have been watching and following similar trends. It's also great for discovering hidden structures like weather data or customer behavior. And Lara Croft here, it's like exploring a new video game world without a map. You figure out the secrets yourself. It might take a lot longer, but it's up to you and your controlled character to figure out for yourself. We move on then to reinforcement learning. The computer learns by trying actions and getting rewards. Good, well done, or punishments, bad. It improves over time by choosing actions that maximize rewards. Real-world examples would include things like games, AI bots in chess, or video games learning to win by practicing. Robots, teaching a robot to walk or drive by rewarding safe moves. And finance, trading bots buying and selling stocks based on profit feedback. Here we go. Another example might be apps suggesting items and learning from, if you click on it, you basically reward, you've acknowledged the suggested app and potentially you might buy it or subscribe to it, or you're just going to ignore it altogether, and that's deemed to be a punishment in terms of the suggestion of the app. We've then got transfer learning. This uses a pre-trained model from one problem to speed up the learning of a new or similar one. This saves time and data. There is no need to start from zero. Again, there's plenty of real-world examples here. Image recognition, a model trained on millions of photos, fine-tuned to spot specific flowers or dog breeds. Speech recognition, a general language model adapted for accents or industrial jargon, e.g. medical terms, maybe even Latin. Customized chatbots start with a big AI like ChatGPT and train it on company data for customer service. And then finally, again, image generation, tools like Stable Diffusion, fine-tuned for a specific art style. Okay, also used, you can see here, in medical imaging, a model trained on general X-ray images, fine-tuned to detect specific conditions like maybe pneumonia or certain types of fractures. So, hope you were listening to that. Got a couple of questions here. I want you to have a little go, pause the video. Once you think you know, play the video, and I will tell you what the answers are. Which type of learning involves an AI earning rewards for good actions? Is it A, supervised, B, unsupervised, C, reinforcement, or D, transfer? Hint, think of a game where you score points. And question 2, which learning method reuses knowledge from one task to improve another? Again, is it supervised, unsupervised, reinforcement, or is it transfer? Like using old skills in a new level. Okay, pause the video. Here are the answers. C, reinforcement learning. Okay, and D, transfer learning. We then move on to A4.1.2, hardware requirements for machine learning. In this brief topic, we're going to be identifying hardware platforms for machine learning. Again, compare the CPUs, GPUs, TPUs, MPUs, ASICs, and the FPGAs, as we mentioned before. Explain edge devices, cloud platforms, and HPC centers. Okay, so why does hardware matter? Why is it important in terms of generative AI, in terms of machine learning? And machine learning needs lots of data and processing power. The right hardware makes training faster and a lot more efficient. Think of it like cars on a racetrack. Some are faster, some more fuel efficient, others built for specific races. So let's start by looking at computing platforms. We've got standard laptops, a MacBook or a Windows laptop, great for learning and small projects. Dedicated workstations, faster with GPUs, e.g. NVIDIA RTX. Edge devices process data where it's collected. IoT, Internet of Terms, refers to a network of physical objects or things which are fitted with sensors, software, and connectivity so they can collect and exchange data over the internet. Cloud platforms rent GPUs, TPUs online. AWS and Google Cloud are examples of these. And HPC centers, super powerful research facilities. Okay, so that's obviously the most powerful there. So let's break it down. A CPU, you've all heard of these, the central processing unit. General purpose, can do many tasks. Okay, good for small machine learning projects. Too slow for large-scale deep learning projects. Whereas NPUs, neural processing units, found in modern laptops and phones, Apple and Microsoft Copilot, specialized for neural networks. The faster performing AI tasks with low power usage. Then we've got GPUs, the graphic processing units, thousands of small cores, parallel processing, excellent for training deep learning models, much faster than CPUs for machine learning. Okay, we've got TPUs, tensor processing units, and these were created by Google and built specifically for machine learning. Great at tensor operations, basically matrix maths, often used in Google Colab and Google Cloud. How it works, you've got inputs and you've got outputs, and you've got a high bandwidth memory. This is where the matrix multiplication unit and the activation unit live. Massively powerful and fast mathematical matrix calculations. Just to clarify, a tensor is a mathematical term for an array with 3 or more dimensions. So a scalar is just one number, like an integer, 5. A vector is a list of numbers in a line, example 2, 4, 6, using Python, like a Python list. A matrix is a number arranged in rows and columns, a bit like an array, like a table. A tensor is basically when you go beyond that. Numbers are arranged in 3D or even more, like a cube of numbers or even higher dimensions. Then we move on to application-specific integrated circuits, ASICs. Custom-built chips for one specific task. Super efficient, very, very fast. They are expensive. Obviously, they're custom-built, so they will be very, very expensive, and they're not flexible. An example, Apple A series chips and Qualcomm Snapdragon. Okay. And finally, we've got FPGAs, field programmable gate arrays. These can be reprogrammed after being made. They offer a balance between flexibility, like CPUs, and efficiency, like ASICs. They're often used for prototyping machine learning hardware. We've got the programmable interconnections here, basically like nodes going through a network. Lots of inputs, and then all controlled by these little logic blocks, and these then produce the final outputs. So, just to recap, choosing the right hardware. Top tip from me: need real speed. If you wanted something to be really, really fast, you should be looking at GPUs and TPUs. Edge devices, MPUs and ASICs. Future updates, FPGAs. Low cost, older GPUs. Cloud devices. Need to scale up fast, cloud GPUs and TPUs. Okay, so in summary, hardware choice depends on speed, it depends on cost, depends on flexibility, and it depends on scale. Laptops, obviously good for learning. GPUs, TPUs, large-scale machine learning. ASICs and FPGAs, specialized systems. Cloud, HPC, biggest, most powerful workloads. Don't confuse the processors. The CPU, general purpose. GPU, parallel processing. TPU, Google chip for tensors. MPU, customer AI chips. ASICs, specialized fixed task. And FPGA, they are reprogrammable. Okay, so let's ask you a few questions on these. Question 1, which processor is best for parallel tasks? Is it A, B, C, or D? And which hardware is custom built for one specific job? Is it again NPUs, TPUs, ASICs, or CPUs? Pause the video. When you've got the answer, press play and I will tell you what they are. Here we go. B, the GPU, and C, the ASIC. Okay. So, to summarize everything really quickly, AI versus ML versus generative AI. AI is the broad field of smart machines. And machine learning is systems that learn from data, and generative AI creates new content. Types of machine learning, we said there was supervised, which learns from labeled data, spam filters, handwritten recognition. Unsupervised finds hidden patterns, customer groups, Netflix recommendations. Reinforcement learning learns from rewards and penalties, games, robotics. Transfer learning reuses trained models for new tasks, medical imaging, chatbots. Then we move on to deep learning. This uses artificial neural networks, ANNSs, with many, many layers. Powers image recognition, speech recognition, and self-driving cars. And then finally, just to recap on the hardware, we've just mentioned this: CPU for general purpose, GPU, TPU, parallel processing, and deep learning. NPU, ASICs, efficient AI tasks. FPGAs are reprogrammable, balanced option, and cloud and HPC scalable for big workloads. That is it. That is the end of this video. I hope you've enjoyed it. I hope it's a good start into the brand new topic that is machine learning from the IBDP Computer Science course. The next video will be video 4, and that covers everything for standard level, and then the ones in between, video 2, video 3, are for the higher level. Okay, I will see you next time. Thank you very much indeed for watching. Bye for now. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.